Hello. One of the biggest challenges both math teachers and students face is getting students to have that inspiration. And I think this goes for most subjects, but math in particular, because in math class we often focus on pure math or just the numbers, like number theory. And sometimes it seems kind of detached from the real world. Much like school seems somewhat detached from the real world. We hear people all our lives talk about the, quote, real world, which is apparently not the same as the school-based world. And it's true that the way humans interact with one another and the way rules are applied and the way theories are applied in practice, on paper, it's one way, and oftentimes in the real world it is something a little different, or at least includes a little element of something that we don't quite learn in school. But when it comes to maths and sciences and engineering and physics and medicine and things like that, the theory really does form the foundation for what's going on. When it comes to business and dealing with organizational behavior and psychology, of course, there's a broad range of behaviors and ideas and thoughts and cognitions that don't quite follow the logics that some people might develop or might think are best. Epistemologically and ontologically speaking, there can be different realities, and our understanding of these different realities might actually model somewhat after these Venn diagrams, where we've actually got separate realities, and within each of these there are different subgroups or subsets that have intersectionality, but they're not entirely the same. But there is that superset, so here I am applying math. But if you're looking for some sort of inspiration, that basically that students and young adults and people throughout their lives can find that by doing a little bit of research. Nowadays things are much different than they were 20, 30, 40 years ago, where people who are struggling with concepts in school or struggling with what to do with their life or how to make more money or how to get a better job or how to develop more skills have nearly endless resources, at least in the English language, online. So here I typed into Google real-world applications of math, and I came across a site from the University of Northern British Columbia up in Canada, and they've got some examples of fields. So algebra is found in computer science. Now, for those of you who are familiar with coding, there's a strict set of rules and syntax that has to be inputted into the computer to return a specific result. And the same is not quite the same with people, or the same can't be said with people, which is why perhaps people who are very skilled in mathematics and computers have a little trouble with people sometimes, a little trouble with communication, because languages, even our humanistic languages, don't follow a strict set of rules like algebra does or like computer science does. But in these fields, if you are looking to get into these lines of work, then you'll need to be good at algebra. Or if you are naturally good at algebra, then these might be good lines of work. Or if you are looking for a reason to become motivated to learn something new in the maths, you can look at these types of informational websites, and it'll let you know where you're going to apply that. Now, each and every concept that you learn in an algebra textbook might not apply directly in each of those situations, but developing a fluency in the general processes and the logic and the rules and the applications of those rules is going to give you some breadth and some skills that can be directly applied in the workplace and overall in your daily life even. When it comes to probability and statistics, understanding how to figure out the probability of a random event, looking at frequencies of things that happen in our neighborhoods, looking at, again, statistical data from how often things occur, under what conditions, what correlated or conditional causal factors are related to specific instances. We can better understand the world around us such that we're not making broad generalizations, or we're not misrepresenting the probability of something happening. Right, so in, say, a bachelor's degree attainment problem here occurs in one of your homeworks or whatever, then that might help you prepare for a job as a school counselor or as an admissions officer at a university, right? And in various aspects of business, we find things like algebra and calculus, even in applications of the sine waves. Right? If we want to do another Google search for real-life applications of sine waves, sine functions, we'll probably find something about business here. Again, lots and lots and lots of different applications and things that you can find online that can give you that inspiration or maybe draw connections between different subjects or between the real world and this paper-based world that sometimes seems a little detached. There are business cycles. Definitely business cycles, like in retail, for example, consumer goods, they experience seasonal trends which go up and down like the sine wave does. And it might take a little bit of searching through these, but you can find the math of seasonal sales trends and sine waves. I'm sure we'll find something here. Right, and so seasonality, you got videos. There's no shortage of YouTube videos. I understand that's probably like one of the reasons why my page is not exactly blowing up. But basically, when kids are in school and when teachers go to teach the kids in school, there's a stubbornness involved in getting people to understand the value in what's being taught. But textbooks are getting better. If you look at a textbook from 50 years ago, it was mostly just words. And in math textbooks, there are fewer words and mostly just pure math. Whereas today, the textbooks are designed by teams of people who understand what consumers want and what's going to inspire kids. You know, there are different educators who have had many years' experience trying to draw pictures or trying to model data on a blackboard or whatever, and they understand that, you know, a combination of colors and pictures and, you know, some pure math with direct applications is definitely going to work best for most people. And absolutely, you know, that's going to help us, again, draw connections between these topics and between these different fields, such that students today can learn deductively. They're going to look at data and draw inferences and make conclusions based on general rules. They can learn inductively, and they can both draw, again, they can make inferences and kind of generalize the rules in their own mind, and then they can learn the rules and then directly apply them inductively and deductively, right? And there are all these different examples in our textbooks these days. And most of these textbooks are available online for free download as well. So, and then when math gets harder, that's right around the calculus age, right? And I think a lot of people become sort of turned off with math early on. They might not even get to this calculus age, but when they do get to this stage here, they really become frustrated and confused. I think this is the big hurdle here. Understanding why it's important to learn even higher level math, because you can do these different things with calculus, right? And beyond these very general, very basic sorts of applications, you can look at, again, differential. You can look at all these different differential equations. Is probably one of the most difficult types of math you can find, and you can see that all of these different professions are really quite difficult, right? Aircraft, nonlinear dynamics. You know, what does that even mean? So seismology, physics, materials testing. You know, how does Apple figure out what materials to use in its circuits and in its in the cases and things? They have to use all of these different mathematical techniques in the laboratory. All right, photographic development. Of course, Kodak isn't doing too much in the way of that anymore. Nuclear physics, heat transfer, in automotive, right? Again, this is a combination of different fields. When engineers go to build a product, there are various sciences and engineering disciplines involved that are using these very complex heuristics that mathematics teaches us. And calculus is basically just a simplified way, or a way of simplifying the algebra, right? But in probability statistics, maybe that's your thing. You know, you can find drug trials that's been popular, right? You You can see here Sherlock Holmes. If you're a detective, you know, there's probability and statistics, perhaps not even known by that name, right? Modeling the likelihood of geese returning, or of a certain chemical being introduced in the environment, killing or having some sort of negative impact on the environment. Various applications, again, that we're seeing more and more in textbooks these days. And even if they aren't directly in the textbooks, especially when you get to those higher level classes, you can find applications online, right? And so that's one of the benefits of being a student today. And I'd like to say that it's never too late to learn. While it might require a lot more risk-taking behavior to quit a job or go back to school, there's certainly some room for change in career and change in direction. But probably a serious career change these days is going to require learning or relearning some of these maths and sciences. And so there's all this supplementary material available, which is really crucial, where I'd like to say there's no excuse for students today to fall behind, because there are just so many different tutorials on YouTube and different places where they can find additional information, whereas if they don't understand something in class, they don't need to pay, as in years past, they don't need to pay so much to go out and get a tutor. They just have to put the time in, watch YouTube videos, and then consistently search for specific information and be curious about their studies, which is part of being a diligent student these days. All right, so again, you can find all these different real-world applications, both in broad terms, like the field that you might go into or the type of work that you might do, but you can also find specific, smaller examples of how these techniques are used in the real world by these people. And again, I think that's the number one obstacle, or the number one hurdle that a lot of students face in becoming more interested in perhaps in any subject, is that it has to appeal to them. And so I recommend going out and just doing a little bit of research, being a little curious, being a little exploratory, and getting off the beaten path. You know, instead of social media, go on and just check out how, you know, what skills and what techniques and what types of maths and sciences and things people are using. How could you implement different types of math and science techniques into your daily life, into your career life, right? How could you improve your efficiency and your efficacy at your workplace or in the home, maybe applying a little bit of math? Or what daily routine do you do that could be explained or somehow studied or understood better or improved through applications of math and sciences? The information's out there, it's just a matter of looking. Okay, thank you.